So let's start. This is my thesis defense. My name is Manreev Sangha, and this is my table of contents, how I'm going to be presenting this. Research title, introduction, related literature, methodology, results, and finally the conclusion and experience. Title for my research is The Potential Solution to the Plastic Plague, and I go to Naperville Valley High School in Naperville, Illinois. I wanted to research this topic because I believe that it is the most important alongside climate change. And I noticed this problem of how plastic is piling up on a lot of beaches when I went overseas. I wanted to know just how the plastic on the beaches, the oceans, and the streets affect our health and the health of other animals or marine life. All right, the topic being investigated is the potential solution to dealing with plastic pollution in our environment. And the research questions I set for myself is how detrimental is plastic for our environment and what specific methods can be used to help deal with that pollution. And the question and why it's important to answer these questions is specifically for myself so I can keep myself on track to have a good aim for my research. But more importantly, I want to know the health of like how it affects the human body and just how detrimental the health is for humans. The objective for this paper was to show how much of a concern pollution is and how important it is to help solve this problem. For my related literature, I split it up into 5 different sections. As you can see, the problems of plastic on the environment and human health, just like the title says, it's just problems. Contributors plastic pollution. This is how like illegal dumping or landfills or like waste management is, and that's what we're talking about there. And microorganisms is the first method that I found, which is naturally occurring, and how like biodegradation is. Then the second method I found was nanoparticles, how man-made degradation affects plastic. And then the last one is comparing the two methods and seeing the efficiency between the two. Okay, for the related overview of related literature, this is an infographic I made on how the human-made plastic goes into our environment, goes into animals, and finally returns back to us in our bodies. First, we produce the plastic waste, and then through mismanagement of waste, we release it into the environment. The plastics break down into a smaller plastic called microplastics, and this goes into animals. And as we know, since we eat a lot of animals, this eventually goes into our body. But not only that, the livestock that produce manure that is used for the crops, the microplastics also go into the crops and contaminates like other diets for animals. The effect of microplastics on human health is just as important as the effects on the environment. And according to different studies, a lot of the human lung tissue gets affected when microplastics get into the human body. And as a result, this can contribute to respiratory conditions such as chronic inflammation, fibrosis, or even smaller conditions like asthma or chronic ones like obstructive pulmonary diseases. And it's important to know more about the effects of human health to help determine what is needed to actually solve it. Another part that affects the human body is the blood. A lot of the microplastics that we eat get eventually makes their way into the blood system. So we are essentially just like having a lot of plastic like circulating through our body. One of the most important ones I found is the microplastics affecting the placenta. And for people who don't know what the placenta is, it's the female organ that is used to provide nutrients to and like oxygen and nutrients to a developing baby. And obviously, this is important for the long-term fetus's growth. These microplastics carry chemicals known as endocrine disruptors, and they pose potential health risks to the human health and the fetus. Effects of the microplastics are quite adverse on both the maternal and fetal health. Second one is the contributors to plastic pollution. This over here is a graph I made, and this is of the treatment of plastic in the US in metric tons. As you can see here, inadequately waste is not like a big issue at all in the US. It's basically zero. Litter is a little bit under 1 metric ton. Illegal dumping, it has a range between around 0.3 to 0.6. And exported inadequately managed waste. This is when the US or other countries export waste to other countries to deal with. And when that happens, the countries usually have jurisdiction over the plastic waste. So they don't really take into account of like where that plastic actually goes. As you can see here, it's somewhere around 0.3 to about like 1.2-ish. And then mismanaged waste, this is something like just plastic that piles up on the ground, or it's plastic that ends up in our trash cans instead of recycling bins. This is quite a huge range because there's just so much of it and it's pretty hard to keep count of. So it's about 1.2-ish to about 3.4. And also, I want to note that other things like uh, urban runoffs, which happen to like plastic that ends up in the cities, they uh, go run down into like the ocean. I don't know how to explain it, but it's plastic that ends up on the streets. They get into the ocean through rainfall, and there's also in the ocean stuff. There's also fishing gear, which we call ghost nets, because this is unused nets that were used to catch fish, and a lot of the fishers or fishermen like just leave it out in the ocean. It's also important to take care of that as well. Now, for the first method, the microorganisms, this is the table, and these are the highest microorganisms that I found that degraded the plastic most. As you can see here, in the weight loss milligrams, we have these top three right here that degraded most. However, they also took quite a long time with 504 hours. And I also want to note that there are two different types of biodegradation, anaerobic and aerobic. Aerobic is when you need oxygen-rich bacteria to degrade plastic. So this is good for where like oxygen is present. So somewhere out in the oceans or uh, like just air. And the anaerobic bacteria is when there is an absence of oxygen. As such, the biodegradation uses electron receptors such as nitrate, sulfate, iron, manganese, or carbon dioxide. There's a lot more, but I just listed off the basic ones. This is good for putting bacteria that needs to degrade plastic in oxygen deficient areas. So think of like landfills. And essentially, biodegradation is the change of structure and materials, in this case, plastic, by utilizing a physical or chemical change. However, instead of synthetically like humans, this happens naturally in the environment. And the second method I found was using nanoparticles. Nanoparticles that I found were silver, titanium, and gold. As you can see, the percentage degradation for they didn't specify the exact amount of plastic they used, but assuming that it's probably somewhere around milligrams or so, degrading about 64.5%, 68% plastic is quite a huge amount. And there's also a density of polymer as well. So low density polymers, you can think of like plastic water bottles or like you buy at Costco. And then you have a hard or high density polymers. You could think of this as something like rugged plastic that you would take on a camping trip. So nanoparticles have like organic or inorganic matrices. we're going to be looking at the inorganic ones because this is the man-made ones. And such. Oh, the byproducts for nanoparticles is quite a huge amount. I can't really list them all because of all the different amount of nanoparticles and all the different byproducts that are made from those different nanoparticles. All right, comparing the microorganisms and nanoparticles, like the microorganisms are a lot slower, but they are safer in the sense that since they happen naturally, we don't have to worry like almost at all about the byproducts that microorganisms make. It is also like pretty hard to compare the two microorganisms and nanoparticles because as you can see, the time taken between nanoparticles and ours is different. Like the amount that it degrades is also different. So, and they're also pretty situational as well, since nanoparticles are used for degrading between like for like plastic with there's like a lot of plastic at once. Since they have a pretty high degradation rate, it's pretty good for just degrading a lot of plastic. Microorganisms are good for degrading plastic that is more spread out per se because it reduces the harmful byproducts that may happen after biodegradation. And for my methodology, um, what I used, like the primary purpose and goal of this study was to determine if microorganisms or plastic-eating bacteria and nanoparticles would be a viable solution to the lower the amount of plastic waste output by humans. And this type of research was conducted by a secondary literature review based on articles such as Science Direct, Google Scholar, and the National Medicine Association, I think the name of it was. A qualitative method of analysis was used in this research paper to understand the effect of plastic pollution and use of fungi slash microorganisms and nanoparticles. The solutions found this can help plastic pollution like a lot further. And for the results, like I said before, they are hard to compare. However, I've determined that nanoparticles would be the better choice. Although the byproducts may be more harmful and there's a lot of compounds that we need to look at, it's still nanoparticles are man-made. So they're basically limitless. As technology increases, nanoparticles will get better. However, microorganisms that appear naturally in the environment, you can improve them, sure, but they have a limit to how much it can be improved. Obviously, each method is still very situational, but like in a general aspect, nanoparticles would be worth our future investment. Then for the conclusion and experience. My main research question, to restate it, was how detrimental is plastic to our environment and what specific methods can be used. The methods discussed microorganisms and nanoparticles. And after a thorough analysis, I found that nanoparticles would be the better choice between the two. And it's important to research more about this since plastic pollution it's going to keep growing because like 100 years ago, after the creation of plastic, it has helped us. But now we're just being aware of just how detrimental it is to the environment and human health as well. And the limitations for this research paper was that it is on other research, so it's a secondary analysis. It's not primary, as I haven't done anything with any experiments myself. And I think I'm gonna end it off here.
Okay, great. You want to share your experiences about the Gifted Gabber program?
I'd like to thank first Dr. Lilova's lectures and like her content helped me understand more that there is to know about nanoparticles. And when I asked her about like what I should do, like when she asked me like what my topic was, I said I was going to do like comparing microorganisms and nanoparticles. And she also helped me send links for the microorganisms and some of the nanoparticles as well, which helped me get started. And I'd like to thank Professor Virgil for the guidance on my format, writing style, outline, and a lot of the other things. He even helped me stay about an hour after class to look at like what my research has so far. It's helped me check everything. I thank both of you professors for helping me a lot. And I would also like to thank the Gift Gabber Research Association for allowing me to write my research paper and publishing it. It's quite exciting for my research to be published into a journal and having it actually cited by a ton of different other people. But it was pretty hard. I mean, like the content that I had to write was quite a bit over 6,000 ish words. But after finally being done, it's quite relieving. I'd also like to point out that um, don't procrastinate. Staying up 2 in the morning to finish a section because it's due that day is not fun at all. Yeah, I am very tired and my sleep schedule is in shambles.
Great. Thank you for those kind words, Manreev. Wonderful.
It's kind of a question and it's kind of a suggestion. What about combining both? What about using both? Microorganisms and nanoparticles. Yes.
Like how would you like define like both? You mean
That's
like
what I was thinking. So imagine you have the nanoparticles and you have the huge surface, right? And you get somehow you get the microplastics on the surface of the nanoparticles and it immobilizes them. So they're not practically moving in the environment like they were moving before. So they're immobilized.
Oh, so we have a lot of the nanoparticles in one place, or like the
And we get
plastics
the
in one place. Yeah.
Yes, and we get them there, so at least they're staying there. They're not going around, and then the microorganisms can work on them. It's just an idea, just came to me when I was listening to you.
I don't see like adding the two. I'd say it like I said before, it's gonna be like difficult because microorganisms are a lot slower since they are naturally occurring, obviously. Like degrading them are a lot slower, but it is also safer, right? So
That's the idea,
that's what I'm saying. It might take a lot of time and research to do it, but it might also be possible. But I still say that if we are able to research nanoparticles a lot more to reduce like side effects, like harmful compounds, I still think that like after maybe like 50 or so years, nanoparticles can clean up basically all the plastic that we have.
Yeah, this would be great. Thank you.
Okay, fantastic.